In example 1, we are going to start verifying a trig identity. It's very similar to what we did with simplifying, but this time we're going to verify. We're going to show that this side is indeed equal to that side. Now, you can work with either side first. So if we wanted to work with this side first, we could. If we want to work with this side first, we could. There's also very different ways you can go about verifying these identities. There's not just one clear way each time. So what I do on here or what I do with the try this, you might have something slightly different, and that's okay as long as you are using your identities the right way. If you ever have a question on if your way is correct versus the way that I have it, I would be happy to take a look at it and let you know. But again, there's a lot of different ways to do a lot of these different problems. So feel free to ask at any time if you could have done something else. So here we go. In example 1, we're going to verify. Now, what we want to do every time is we're going to have a statement of what we're doing. And with the statement, then we also need to write down what the rule is. So what rule or what property identity did we use in order to go from one step to the next? So you really have to make sure you're only doing one step at a time and that you're showing your work. So my very first step here that I would do is I would take a look at the top here, seeing that I have a cosecant squared x minus 1, noticing that that's a Pythagorean identity. And I can change cosecant squared x minus 1 into cotangent squared x. So I have cotangent squared x over cosecant squared x. Oops. Let's make that a little better. And that's still equal to cosine squared x. I don't need the equals part on there, but I do need to list down what my rule was for number 1. And I used a Pythagorean identity, so I'm going to say Pythagorean. And if you're unsure about that, remember your identity. And so go back and look. If you need your identities out, if you haven't memorized them yet, you can look at it. All we did was move around that Pythagorean identity. Then step 2, I see that I have cotangent squared divided by cosecant squared x. And so what I'm going to do is I'm going to split these two up so that I can work with each one separately. So I'm going to rewrite it as cotangent squared x divided by cosecant squared x. And that's just an algebra rule. Step 3. Now I'm going to start changing things in terms of sines and cosines. So working with one thing at a time, I'm going to start with my cotangent squared x, and I'm going to change that to cosine squared x over sine squared x. And I'm still dividing by cosecant squared x. And my rule here is that I used a quotient identity. I changed cotangent to cosine over sine, which is one of my quotient identities. Then in step 4, I'm going to go ahead and I'm going to change my cosecant squared. And I can use a reciprocal identity. I can change cosecant squared into 1 over sine squared. So I'm going to leave my first one alone, cosine squared x over sine squared x. I still have my division sign. And then cosecant squared I'm going to change to 1 over sine squared x. And again, this I used a reciprocal identity. Then number 5, I can go ahead and now change division to multiplication. So if I'm going to divide two fractions, my next step is to change the division to multiplication and take the reciprocal of the 1 over sine squared. So I have cosine squared x over sine squared x times sine squared x over 1. And that was just an algebra skill, just a matter of simplifying. And then my next step, I can do another algebra skill, which if I take a look at the other ones, I have a sine squared here and a sine squared here that can cancel out. And all I'm left with is cosine squared x. So my last rule would again just be algebra simplification. And so what I've done is I've proved that cosecant squared x minus 1 over cosecant squared x is indeed cosine squared x, which is what I ended up with down here. The nice thing about verifications versus simplifying is that you know what you need to get to. So you know when you're done. As soon as that left-hand side and the right-hand side are the same, you know you've done it correctly. Next, I'd like you to pause the video and go ahead and do the try this. Again, if you need help on it, let me know. So pause it now, unpause it when you're ready to check your answer. If you did the try this correctly, here's one possible way. Remember, there's not only one right way. So if yours doesn't match with mine, call me over. I'll be happy to take a look at it and see if the way that you did it still works. So what I did in my first step is I changed secant squared theta, this one right here, and I changed that into 1 over cosine squared theta. And then it's still being multiplied by cotangent squared theta, and I'm still subtracting a 1. And so my first rule here was a reciprocal identity. Then I went and I changed the cotangent squared using a quotient identity. So I have 1 over cosine squared theta times cosine squared theta over sine squared theta minus 1. And this is my quotient identity. Step 3, I went ahead and I multiplied. So I can go take a look. This cosine squared and that cosine squared can cancel, leaving me with 1 over sine squared x, or sine squared theta, minus 1. And that was just an algebra. And then in my fourth step, 1 over sine squared, I can make into cosecant squared theta using my reciprocal identities. And then I have a Pythagorean identity, cosecant squared theta minus 1 is the same thing as cotangent squared theta, which is a Pythagorean identity. And I've gotten back to where I started from. I proved that this left-hand side is indeed the right-hand side of cotangent squared theta. If you have questions, let me know.